Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the trigonometry and trigonometric ratios. Let's start with the lecture. Best of luck. Trigonometry. Trigonometry is basically composed of two words, trigno and metron. Trigno means triangle and metron means measure. Trigonometry is all about measurement of the triangle, measurement of the angle, measurement of the sides, linking the sides with the angle. So trigonometry is basically study of a triangle and specifically study of a right angle triangle. Most of you must be surprised why such a huge topic just for study of the triangles. The study of triangles are very important with respect to mathematics. The triangles are everywhere, especially the right angle triangle is everywhere around us. Our whole world is composed of many right angle triangles. If we are able to solve for specific angles and sides for these right angle triangles or specifically the triangles, we can solve many practical problems. For example, if you see the plane in the sky, your vision is making a right angle triangle with the sky. If you are able to study this triangle, you can find the elevation of the plane, the distance of the plane, the velocity, etc., the data with respect to this plane. If you see a tree and the shadow, you can make a right angle triangle out of it. You can easily measure the height of the tree without climbing the tree. If we are standing at a fixed point in front of the mountain, we can also form a right angle triangle with respect to the mountain, and we can measure the height of the mountain if we apply the trigonometry in this right angle triangle. This is how the height of the famous peaks like the Mount Everest and other peaks are measured. We do not climb the top of the peak with the inch tape or any other device to measure the height of the Mount Everest or any of the peaks. We use trigonometry to measure such heights. Further examples, if we are having a ladder on the wall, it is also making a right angle triangle. So basically our world, everything around us is composed of many right angle triangles. So study of right angle triangle or triangles is very important for us. That's why we got trigonometry. Trigonometry is just the measurement of the triangles, the angles, the sides of the triangles. So you got the basic understanding of the trigonometry, why we study the trigonometry. Trigonometry is very important. It is not only in this class, it will also be helpful in your future competitive exam. The basics of trigonometry like the trigonometric ratio, identities, it will stay for long time. So pay your full attention. If you complete the series on the complete trigonometry, I assure you, you will be able to solve all the questions related to trigonometry and you will excel in the future exam. So just be with me. Let's move further. We will study trigonometry with respect to right angle triangle, but it does not mean trigonometry is only restricted to right angle triangle. It is also applicable in acute triangle, obtuse triangle, other type of triangle. But for this class, we will study the trigonometry for the right angle triangle, which cover most of the trigonometry. In this right angle triangle, we will study two components, the sides of this triangle and the angles of this triangle. The relation between the angle and the side will result in various trigonometric components that are trigonometric ratio that we will study as we progress through this lecture. So we will study the trigonometric sides and trigonometric angle. These are the two major components. Firstly, let's study the trigonometry angle. This is a right angle triangle. It means one of the angle is 90 degree. So this angle is 90 degree and this is the symbol of 90 degree angle. Other two angles are not 90 degree angle. Let's assume one angle as angle theta. Here this angle, angle theta, we call as trigonometric angle. One angle of the right angle triangle is the trigonometric angle. One angle is 90 degree, we got two angles, and out of these two angles, one angle we call as trigonometric angle. All the properties of this triangle will be with respect to this trigonometric angle. This is very important. Whenever we are having any questions of trigonometry, you have to identify the trigonometric angle. Once we got the trigonometric angle, then only we apply the formulas or the other stuff of the trigonometry. So this angle for this case is the trigonometric angle, that is angle theta. What will be the third remaining angle? For that we will apply the sum property of the triangle, that is the sum of three angles of the triangle is equal to 180 degree. Let's put the value. We got the third angle as 90 degree minus theta. So we are having three angles of this right angle triangle. One is 90 degree, second is angle theta, which we have called as trigonometric angle. Okay, one angle we have to take as trigonometric angle, rest I will tell you later on. The third angle we got as 90 minus theta. So this is the angle component of the right angle triangle. Let's move to the second component, that is trigonometric sides. All the trigonometric sides for this right angle triangle will be with respect to trigonometric angle, that is angle theta we have seen. Firstly, let's see what are the three trigonometric sides. This triangle is having the three sides. In the trigonometry, we are having specific name for these three sides. That is perpendicular, hypotenuse and base. The three sides of our right angle triangle in the trigonometry are called perpendicular, hypotenuse and base. Which is perpendicular, which is hypotenuse and which is base? Let's see. The side which is opposite to our trigonometric angle is called the perpendicular. Here we have assumed the angle B as the trigonometric angle, that is angle theta. So the side AC which is opposite to our angle theta, the trigonometric angle, will be the perpendicular. So the side AC is the perpendicular. Got it? This is the first side. Let's move to second side, that is the hypotenuse. Hypotenuse is the side which is opposite to 90 degree angle. Here angle A is 90 degree angle, so our side BC will be the hypotenuse for this triangle. Got it? The side opposite to 90 degree angle is the hypotenuse and the side opposite to angle theta, that is trigonometric angle, is the perpendicular. The third remaining side is called the base. So here AB will be the base. In the specific term, base is the side between the trigonometric angle theta and the 90 degree angle. So AB is the base, AC is the perpendicular, BC is the hypotenuse. These are the three names to the right angle triangle sides we give in the trigonometry. Got it? These are the three trigonometric sides. Now let's understand a special case, or we can say a small trick. For the time being, we are saying our angle B is angle theta, that is trigonometric angle. But in the starting, I have said that all the trigonometric sides are with respect to the trigonometric angle. We are assuming angle theta or angle B as trigonometric angle. If we change our trigonometric angle to angle C, let's assume the angle C, that is 90 minus theta, as the trigonometric angle. Let's see what will be the trigonometric side. Are you getting? Angle B or angle theta as a trigonometric angle. We have assumed angle B as trigonometric angle. And now we are assuming angle C, that is angle 90 minus theta, is the trigonometric angle. Let's see what is perpendicular, what is hypotenuse and what is base. For angle C as trigonometric angle, the perpendicular will be the side opposite to trigonometric angle. Here angle C is a trigonometric angle, so the side AB is opposite to angle C. That is AB is the new perpendicular if we are taking angle C as trigonometric angle. Got it? Initially AC was perpendicular, but now we got AB as perpendicular. Let's see what is hypotenuse. Hypotenuse is the side which is opposite to angle 90 degree. So here angle A is 90 degree, which is also 90 degree in the previous case. So BC will be the hypotenuse. So by changing the trigonometric angle, our BC, that is hypotenuse, is not changed. In the previous case also BC was hypotenuse, and this case also BC is hypotenuse. So hypotenuse is the side which is opposite to 90 degree angle, and it is not changed by changing the trigonometric angle. This is important. Got it? Let's see what is base. Base is the side between the trigonometric angle and 90 degree angle. So here AC will be the base. Here angle C is the trigonometric angle and angle A is the 90 degree angle. Side AC is the side between trigonometric angle and 90-degree angle. We got AC as base. In the previous case, AB was base. Are you observing this? As we change the trigonometric angle, base and perpendicular are also changed, but hypotenuse remain the same. This is very important concept and you should know this. So if someone show you a right angle triangle and ask you what is perpendicular, do not blindly say AC is a perpendicular or AB is a perpendicular. Ask which is the trigonometric angle. If the trigonometric angle is angle B, then AC will be perpendicular. If trigonometric angle is angle C, then AB will be the perpendicular. All the trigonometric sides will be with respect to the trigonometric angle. Hope you got this concept. Note that angle A is 90 degree, only angle B and angle C will be trigonometric angle. Angle A is 90 degree, so it cannot be the trigonometric angle. Let's take a small question for you to check your level of understanding whether you got this concept or not. We have taken an rotator triangle PQR. Here angle Q is 90 degree and angle P is angle theta, which is the trigonometric angle. You have to tell me which side is perpendicular, which side is hypotenuse and which side is base. Our angle P is the trigonometric angle and angle Q is a 90-degree angle. You are having 10 seconds. Just do the calculation in your mind. Your time starts now. Let's see what is the answer. Here angle P is the trigonometric angle. So perpendicular will be the side which is opposite to trigonometric angle. So the side QR will be perpendicular for this triangle. Got it? The side opposite to trigonometric angle. And hypotenuse is the side which is opposite to 90-degree angle. So the side PR will be the hypotenuse for this triangle. And what will be the base? The third remaining side is the base. So PQ will be the base. So got it? We got perpendicular, hypotenuse and base. I have specially taken an inverted triangle because in a simple plane triangle you can easily tell which is perpendicular, which is base and which is hypotenuse. As we got inverted or the rotator triangle, it got slightly confused to tell which is perpendicular, base and hypotenuse. So this exercise will help you to do the same. Got it? We have done the trigonometric angle concept and also the trigonometric side concept. Let's move to trigonometric ratios. Trigonometric ratios are very important and this will remain with you for a long time. Maybe in your competitive exam or maybe with your career too. I personally have used the trigonometric ratios, the advanced form of trigonometric ratios in my 15-year career of engineering design. So these trigonometric ratios are really very important and may remain with you for a long time. Okay, so pay your full attention please. Let's study about the trigonometric ratio. For that, let's take our right angle triangle ABC, which is having 90-degree angle at angle B. For this triangle, let's assume angle A as trigonometric angle and let's take this angle as angle theta. And just now we have seen perpendicular, hypotenuse and base as the three trigonometric sides for this triangle. Perpendicular is the side which is opposite to trigonometric angle. So BC is the perpendicular. AC is the hypotenuse, which is the side opposite to 90-degree angle. And base is the side which is between the trigonometric angle and 90-degree angle. So AB is the base. So we got the three trigonometric sides of this right angle triangle. And trigonometric ratios are just the ratios of the trigonometric side. Trigonometric ratios, the word ratios are coming. And ratios of what? Ratios of the trigonometric sides. The various combinations of the various trigonometric sides, the ratios of various trigonometric sides will give different trigonometric ratios. I will just explain you what are these different trigonometric ratios. But just understand that what is trigonometric ratios? Trigonometric ratios are the ratios of the trigonometric sides. We are having three trigonometric sides, perpendicular, hypotenuse and base. Various combinations of these three sides will result in various trigonometric ratios. So let's see what are the various trigonometric ratios. We are having total 6 trigonometric ratios. These are sine, cosine, tangent, cosecant, secant, and cotangent. These are the 6 trigonometric ratios. These 6 words may be new to you. Just pay attention. This is the basic foundation of trigonometry and will be helpful in solving the future questions. So we are having 6 trigonometric ratios, which are sine, cosine, tangent, cosecant, secant, and cotangent. In short, we write sine as sine, cosine as cos, tangent as tan, cosecant as cosec, secant as sec, and cotangent as cot. So you should remember all these 6 trigonometric ratios, the name sine, cos, tan, cosec, sec, and cot. As we progress through this lecture, these 6 trigonometric ratios will be repeated many times. So they will automatically go to your subconscious mind. Don't worry about the name of these 6 trigonometric ratios and what it is. I will just explain you. Okay? I have just told you trigonometric ratios are the ratios of the trigonometric sides. And before that I have told you that trigonometric sides are with respect to the trigonometric angle. Here our trigonometric angle is angle A, which we have taken as angle theta. So all these trigonometric ratios will also be with respect to this trigonometric angle, that is angle A or angle theta. So this is a linking. You should know that everything is with respect to certain trigonometric angle. And in this case, the trigonometric angle is angle A or angle theta. So firstly, let's see what is sine, the trigonometric ratio of sine. We write sine as sine theta. Here theta is the trigonometric angle. Here sine theta does not mean we are multiplying sine and theta. It is a notation of writing the trigonometric ratio sine theta, and sine theta is the ratio of perpendicular and hypotenuse. So we will write sine theta is equal to perpendicular over hypotenuse, which is equal to BC upon AC. BC is the perpendicular and AC is the hypotenuse. Got it? Trigonometric ratios are the ratios of the trigonometric sides, and sine theta is the ratio of perpendicular and hypotenuse. Got it? Let's see what is cos. Cos is the ratio of base is to hypotenuse, that is base upon hypotenuse. We will write cos as cos theta. Theta is the trigonometric angle. So cos theta is equal to base over hypotenuse, which is equal to AB upon AC. AB is the base and AC is the hypotenuse. Tangent, that is tan. We will write it as tan theta. The trigonometric ratio tan is the ratio of perpendicular and the base. Perpendicular upon base is equal to tan theta. BC is perpendicular, AB is base, so we got tan theta as perpendicular over base. No need to remember the complete list of all these 6 trigonometric ratios. Just you have to focus on first 2 trigonometric ratios. Rest all the 4 trigonometric ratios will come automatically. That I will explain you how to do so after completing all the 6. Okay. Similarly, cosec is the ratio of hypotenuse over perpendicular, that is AC upon BC. Sec is the ratio of hypotenuse upon base, and cot is the ratio of base over perpendicular. So we got cosec as AC upon BC, sec as AC upon AB, and cot as AB upon BC. So these are the 6 trigonometric ratio you should remember in the sequence, that is sine, cos, tan, cosec, sec, and cot. So let's again observe all these 6 trigonometric ratios and let's observe them in very deep. Just remember sine and cos. Sine is perpendicular over hypotenuse. Cos theta is equal to base over hypotenuse. Got it? Hypotenuse is the longest of all the 3 trigonometric sides. So hypotenuse will come in the denominator. Just a remembering technique. Hypotenuse will come in the denominator for sine and cos. Sine is perpendicular over hypotenuse and cos is base over hypotenuse. Next, tan. Tan is perpendicular over base. Tan theta is basically sine theta upon cos theta. If we divide sine theta by cos theta, that is perpendicular over hypotenuse upon base upon hypotenuse, this hypotenuse will cancel out. We got perpendicular over base. So tan theta is basically sine over cos. Whenever value of sine and cos is given, we can easily calculate tan theta as sine theta upon cos theta. So this way you can remember tan theta, no need to remembering specially the formula of tan theta. Just divide sine theta by cos theta, you will get tan theta. Moving next, here cosec, sec and cot are reciprocal of sine, cos and tan. Interesting. Let's see. Cosec is reciprocal of sine. Sine is perpendicular over hypotenuse. Cosec is hypotenuse over perpendicular. Sine is BC upon AC. Cosec is AC upon BC. Interesting. Cosec is just the reciprocal of sine. Similarly, sec is reciprocal of cos. Cos is base over hypotenuse. Sec is hypotenuse over base. Lastly, cot is the reciprocal of tan theta. Tan theta is perpendicular over base and cot theta is base over perpendicular. So no need to remember the last three trigonometric ratio. If you got sine, cos and tan, the formula of sine, cos and tan, just do the reciprocal. You will get cosec, sec and cot. But you should remember all the 6 trigonometric ratios in the sequence. That is sine, cos, tan, cosec, sec and cot. Tan theta is sine theta upon cos theta. Cosec theta is 1 upon sine theta. Sec theta is 1 upon cos theta. Cot theta is 1 upon tan theta. So just remembering sine and cos, you will get all the 6 trigonometric ratio. Got it? Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. Let's move further. You have understood the basic concept of trigonometric ratio. Here whatever the angle theta is, that will come in front of the trigonometric ratio. Suppose the theta is 30 degree, then we will write sine theta as sine 30 degree, cos 30 degree, tan 30 degree and respective trigonometric ratio with angle as 30 degree. It does not mean we are multiplying sine with 30 degree. It is a notation of writing the trigonometric ratio, sine 30 degree. Moving further, these trigonometric ratios are fixed for a particular angle. It means that sine 30 degree will have some value that will be fixed. To understand this concept, let's take 3 triangles with the trigonometric angle as 30 degree. Here all the 3 triangles are having the trigonometric angle as 30 degree, but the size of all the 3 triangles are different. The first one is smaller and the last one is the bigger one. The concept is that the value of sine 30 degree in the first triangle, the second triangle and the third triangle will be constant, that is same in all the 3 triangles. This is sine 30 degree in the first triangle and this is sine 30 degree in second triangle and this is sine 30 degree in the last triangle. That is ratio of perpendicular over hypotenuse in all the 3 triangles will be equal to each other. Whatever triangle you take, smaller or larger, this ratio will be equal to each other. This you can also prove using the concept of similarities, but I am not going into the detail of that concept. Just note that sine 30 degree, the value of sine 30 degree, that is ratio of perpendicular over hypotenuse in all the triangle with angle as 30 degree will be same. That is, it is constant. Similarly, you can take cos 30 degree, that is base over hypotenuse. The ratio of base over hypotenuse in all the 3 triangles will be equal if this angle is 30 degree. The trigonometric angle is 30 degree. So we got a concept, that is the trigonometric ratio values are fixed for specific angles. If we take sine 30 degree, it will have some value. If we take sine 60 degree, it will have some value. If we take sine 0 degree, it will have some value. Sine 90, sine 45, sine 70, sine 75, whatever angle you will take, it will have certain value with respect to the trigonometric ratio. And that value is constant. Whatever triangle you take, smaller, bigger, any triangle, if the trigonometric angle is 30 degree or whatever angle you want to take, the ratio of the trigonometric sides will be fixed or constant. This is the concept, what is the value, what is the angle, that we will cover in the lecture when we cover the trigonometric ratios of specific angles. That is a separate lecture, but note that this value is fixed for specific angles. Got it? In the next lecture, we will take the NCERT examples, and the examples are very well written. So do not skip the lecture. The NCERT examples are very, very good. Okay? So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA CLASSES. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list, and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for, and have a great day. Bye.